Let's take a look at some Venn diagrams, and this will help you visual learners out here. If we say the probability of A is 0.3, what they're talking about is this whole entire red circle is 0.3. They say the probability of B is 0.5, so this whole entire blue circle is 0.5. And then they say A and B, so the overlapping portion is 0.1. So this inner thing is 0.1. So we do not just take this 0.3 and throw it in A, or this 0.5 and throw it in B. Since we don't want to double count, we actually have to get rid of this 0.1 in both those circles. And in circle A, it will be 0.2, and in circle B, it is 0.4. Now, and this makes sense, because in this whole entire red region here, if I look at all of this, it's a grand total of 0.3. And if I look at the blue region, this whole entire blue region is 0.5. So the probability of A is 0.2 plus 0.1 or 0.3, because I want this whole entire red region. Probability of B would be this whole entire blue region, which is 0.5. A and B just wants to go ahead and focus on this pink inner region. And from the previous example, this was 0.1. Now they want A or B. So if you look at A, A was 0.3, and B was 0.5. Now the problem is we just went ahead and counted this part of B, but we also counted this section part of A. So what happens is I just counted the same section twice. So what happens is we double count it. So we need to subtract it one time. So I subtract 0.1 only once because I double counted. It only needs a single count. So the answer to that is 0.7. Probability of A and not B. So not B is actually this whole entire region that's not B. And the probability of A and remember it can't be B, is right there. So we want to go ahead and just take a look at that area, since A needs to be included. So the answer to that would be 0.2. Not A is all this stuff. And the probability of B is, well, actually this whole thing, but where do they overlap? is they overlap where the blue and the purple meets, which would just be this section. So that is 0.4. The probability of A or not B, well, not B is all of this. So not B equals 1 minus, and then it says B is 0.5, so not B is 0.5. And the probability of A is 0.3. But notice what we did there is we double counted because not B is all of that. So we actually double counted this green area in here. And how much is this green area worth? That green area is 0.2. So what we need to do is 0.5 plus 0.3 minus 0.2. So we don't get any double counting. And that will give you 0.6. This one will be very similar to the one we just did, so I'm going to skip it. The probability of not A and not C, or not B, so we want everything that's not involved in those circles. And this was 0.2, this was 0.1, and this was 0.4. So if there's a total here of 0.7, so we want 1 minus 0.7, this will give us 0.3. The probability of not A is right here, so that's probability of not A, that would just be 1 minus 0.3, which is 0.7. And the probability of not B is 1 minus 0.5, which is 0.5. But the problem is noticed in this area that's being highlighted up top, that's all double counted. And how much is that area on the outside of that? You need to subtract that once. So the blue highlighted area on the outside is 0.3. So 0.7 plus 0.5, that's 1.2, and of course that defies the basic laws of probability. So then you got to subtract 0.3 and you get 0.9. This says the probability of B given A has occurred. So what's our total here? Our total is actually A. So the probability of A is 0.3. So the only place where B overlaps it is in here. So therefore, that probability of overlapping is 0.1. And if you go ahead and do that math, you should get 0.3s repeating. The probability of A given B has occurred. So now this is our total. And if B is 0.5, and the only place where A overlaps it is here. So the probability of that is 0.1. And if you do that, your answer is 0.2.